And do I want to hit record as well here?
No. It's auto recorded. So, Apurva, we are live.
Hello. Good
evening,
from
everyone.
hello from California. Good morning.
Good evening, everyone. It's a great pleasure to welcome all of you to the 13th edition of IGDC. This year, we have had 120 plus eminent speakers sharing their invaluable experiences, insights, trends, and professional as well as personal journeys over the last 3 days. Today in this session, I'm thrilled to have Apurva Shah with us and talk about building the open metaverse. Before we jump into the session, I would like to introduce Apurva. Apurva Shah is a maker entrepreneur. He's a co-founder and CEO of Duality Robotics. Apurva's illustrious career includes the head of creative technology and design systems at Capital One, visual effects supervisor and member of technical brain trust at Pixar, and SVP of global technology at Rhythm and Studios. He is an adjunct professor in various prestigious art institutes across the globe. Apurva's consulting collaborations include a technical advisor relationship with LA-based Spire Animation Studios and a strategic advisor to Mumbai-based creative and technology studio Greenway. His film credits include Ratatouille, Shrek, Finding Nemo, and Toy Story 3. He holds several innovative patents in simulation, rendering, and digital payments. He has served on the SIGGRAPH committee and on the board of the Visual Effects Society. He currently serves as an advisor for the non-profit Kids and Art Foundation. Just for the audience, I'll again once again remind that we have a session for 30 minutes and Q&A reserved for 15 minutes. But we do have a freedom to ask questions in between in a QA tab, and speaker can pick up those questions as he seems fit. The feedback form for this talk will be shared on the Hands-Out tab. Please take a moment to fill this survey. It would help us to improve these sessions better in future. With this intro, I would like to hand it over to Apurva. Apurva, the stage is yours.
Rupesh, thank you so much for the kind introduction, and thank you to all of you for joining. It's a pleasure to be here, and the topic today I think is particularly interesting. The metaverse obviously is a concept that has been growing in its impact, and I'm really excited to talk about this topic because it's sort of a convergence of a lot of different ideas that apply, of course, to multiplayer gaming, but in other areas also of like the spatial internet and just the coming together of a lot of different ideas that have been floating around for a while. So what I'll try to do in the talk today is really ground this idea of the metaverse more formally, because even though you read about it quite a bit, there's still not a lot of clarity around what it actually means. So we'll start by actually defining what the metaverse is, and then from there we'll move on to how do you more formally think about the metaverse. I'll share a design framework with you that hopefully can help you in this way. In addition to some of the background that Rupesh mentioned, I'm also an adjunct professor at California College of the Arts, where I teach metaverse design. So some of these ideas come from what I cover with my class there. And then I'd like to share very much some of the work we've been doing at Duality Robotics, which, by the way, has a wholly owned subsidiary in Mumbai as well. So a lot of the work you will see has actually been done in Mumbai by the team there, along with our team, both here in the US and in Italy as well. So excited to share some of that work just to make these ideas a little bit more concrete. And then hopefully, if there is time, we can take even more questions at the end. Awesome. So I'm going to share my screen. Let me know if you can see it. Rupesh, are we able to see the screen?
Yes.
Awesome. Thank you so much. All right. So I want to talk about this idea of the open metaverse, right? So a little bit of introduction in terms of the Duality team very quickly. We started in 2018. My co-founder, is very much, his background is very much rooted in the physical world. He used to he was at CMU, mechanical engineer, participated in the DARPA Grand Challenge that kicked off the whole self-driving car revolution. After that, he led field robotics at Caterpillar for over a decade. My home, on the other hand, and you got some of my background from Rupesh, I won't repeat, but it's very much grounded in the virtual, and making these fantastic dynamic worlds, like you see this of Paris from Ratatouille, but the underwater world of Finding Nemo, or the sort of sprawling world of Cars. And the conversation that really sparked duality was, what if we combine the sort of creativity and passion that goes into building these amazing Pixar worlds, granted that they're for storytelling, but what if we combine that with sort of the engineering rigor and precision that it takes to build a Caterpillar machine? If you can combine these two things together, then I think there's a possibility of having incredible impact. And oh, by the way, in doing this, we sort of bridge the virtual and the physical world through both data and interaction as well. Turns out this problem is really interesting to a lot of very accomplished people, and we've been able to collect an amazing team. As I said, a part of the team being in Mumbai to work on this problem. And we also, it's a very large, very complex problem, and we have some amazing partners that we work with as well on this journey. So let's talk about the metaverse and try to define it more formally, because today, you cannot escape this word right now. It's at peak hype velocity right now. But I'm going to try to attempt at defining it a little bit more formally, and then we'll deconstruct this definition and sort of put it back together. And I hope that even just through that exercise, you will have a better, more concrete handle on what the metaverse is. So the metaverse is a synchronously shared and persistent three-dimensional context where users, embodied as avatars, navigate immersively and interact through direct presence. If this doesn't make sense right off the bat, don't worry, it's a mouthful, but we'll break it down and look at it more systematically. And I should mention that this is a definition that is very grounded in interaction design. And you see that kind of the way I talk about this definition is really starting with this concept of the core interaction loop. This is foundational to every form of UI, UX, and interaction design work that people do, right? So, you start with this 3D context, what we call the metaverse environment. It could be a sandcastle, it could be a forest, it can be very stylized, it can be very photoreal. Doesn't matter, right? There is a 3D world that you have. And one of the things you're able to do from this 3D world is create perception streams. What do we mean by perception streams? I mean, it's very simple, right? Like right now, as I'm talking to you over this webcast, essentially you're using your eyes to look at what is on my screen or my face, and your ears are taking in essentially what I'm saying. So these are both perception streams. There's a visual perception stream essentially being consumed by our eyes, and there's an auditory perception stream being consumed by your ears, right? And let's pretend for a second that I'm not real. This room around me is not real. This could be a virtual environment. Would the perception stream that you are receiving change? Not necessarily, right? You might see exactly the same visuals, you might see exactly the same audio, but I may not actually be real, right? So it turns out that our senses per se make a judgment of what is real or not real based on the input perception streams, but as such, they don't have any bias, between physical and virtual. So ultimately, what is going to happen to these perception streams, right? They're basically going to go into your eyes, or go into your ears, which is your sensory interface. And then your brain is going to process that information in some way and make a decision, right? So if your eye sees that you're near a door, your brain is going to say, oh, I want to open the door. So it will send an actuation command. It will send a command to your hand to reach out, open that door, right? So that's what we call the action stream. Now, interestingly, your brain is making the decision, but the action is not taken by your brain. The action is actually taken by the muscles in your hand, right? Your brain sends a signal to your muscles to actually go reach out the hand and open the door. So in a virtual environment, so if you are not in the physical world, let's imagine you're actually in a virtual world, your brain can still send that command. But in this case, your finger may move a joystick or press a button to actually initiate that action, right? And again, for our purposes, let's imagine that those things are equivalent, right? And this loop actually runs very, very fast. It can run hundreds of times in a second. And a really very simple example of a core interaction loop is literally your mouse, right? So when you look at your screen, you see a pointer of a mouse, right? That's your perception stream, right? Where that pointer is telling you where the mouse is on your screen. But your hand then moves this device called a mouse, right? So that's your actuation stream. And it causes that little mouse pointer to move around. Now, what your brain does is actually close that loop. Your brain says, my hand moving the physical mouse is actually moving that pointer. Obviously, that is completely an illusion created by your brain, right? Because obviously, I'm moving this physical thing called a mouse, which has nothing to do with my screen as such. It's not a physical action. But your brain is very, very good at fusing these perception streams, action streams. So as long as this feedback loop or this interaction loop works very fast, our brain kind of closes that gap, right? And so if you ask me what is the most magical thing about the metaverse, it is not any particular technology. It is actually this inbuilt ability of our brain to run this interaction loop with so much conviction and fidelity, right? Now let's take this idea of synchronous, right? So actually in the metaverse there isn't necessarily one interaction loop running in this way. There are potentially many, right? So each user on whatever machine they are, or phone, or whatever the device might be, is effectively running this interaction loop for themselves, right? But we say that, but multiple people can synchronously exist in the metaverse. How does that happen? Well, all these individual interaction loops can actually update a server with with whatever changes have happened in their core interaction loop. And then the server can communicate that to all the other interaction loops, right? So if you do this again very, very fast, 100 plus times a second, or maybe at least 60 times a second, then you get this illusion that the world is synchronous, that you're not alone in this metaverse, that there are other people with you. But remember, they're not actually with you in any way. Just like the Zoom call, or just like a Zoom call, I'm not with you. I'm somewhere else. But because we are all seeing each other, updating the world, we feel that we are basically synchronously present in the same place. And I should point out that this kind of synchronous interaction, especially with low latency, with low delay, actually requires a very powerful network with bandwidths far in excess of what you need typically to do messaging or even video calls, right? And so in that sense, this is one of the enabling technologies for the metaverse, right? Like, we really need to have good high-speed connectivity if we are going to participate in high fidelity, large scale synchronous metaverses. Let's talk about this concept of persistence, right? So in the physical world, we take persistence for granted, right? So if you walk into a room and you put a book down on the desk, right, and you walk out of the room, when you come back 2 hours later, you fully expect that book to be there, right? You don't expect it to have moved by itself to somewhere else, right? And so it's the same is true of the metaverse, right? We expect that the metaverse is persistent, that the world state of the metaverse is persistent. So if in a synchronous metaverse, if you move something, I should see that you moved it. And then, if we went away to some other part of the metaverse and came back, we expect to see that thing kind of where it is, right? There's also another more subtle kind of persistence, which I call narrative state persistence, right? So if you look at a game like Animal Crossing, it has seasons, right? So when and in fact, not only does it have seasons, but the seasons can change based on whether you're in the northern hemisphere or the southern hemisphere, right? So this is what I call narrative persistence, right? Because it's actually something unique to the experience. And you can actually have these narrative states persist not only within the metaverse experience, but it could also even persist across the physical and the virtual, right? So in the case of, in this case with seasons. But imagine that if you enter the metaverse when you are in Mumbai and it's raining outside, then if you see the same rain in the metaverse, you will get that sense of narrative persistence. Okay. The next concept I want to pick up is avatars, right? So avatars is essentially what is your representation in the metaverse. And here we have a very famous avatar on the very left, which is, of course, our iconic Pac-Man. And what I'm trying to show here is, and next to Pac-Man, of course, you have a meta-human from Unreal. And both serve the same purpose. They represent you within the experience. One is just a handful of pixels, and the other one is this very high fidelity polymesh with beautiful texturing, very very realistic lighting. And absolutely, one of these representations, one of these avatars, is far more realistic than the other. But in essence, they serve the same purpose. And by the way, avatars don't necessarily have to be realistic. They have to serve, just as in a game, they have to serve the experience you're trying to create. So the fidelity of the avatar, the appearance of the avatar should very much be dictated by what is the experience that you're creating. And then, of course, the reason the avatar exists in the metaverse is both to tell you where you are, right? To localize you within the metaverse, but then also to be able to control, also to be able to interact with that metaverse or others who are in that metaverse. So the other aspect of avatars is obviously how do you control them? How do you actually actuate them, as we said earlier in the core interaction loop, right? And how do others see your avatar being actuated or taking actions in that way? Next, coming to this concept of immersion, which is also very central to the metaverse. And really, there are kind of two main types of immersion. The primary immersion is through sensory hacking, right? So, one of the most compelling ways of doing sensory hacking that we know is through virtual reality, right? So if you put on a virtual reality headset, your eyes are basically now not seeing the physical world. They're only seeing the virtual world. Your audio is also, your ears are covered with headphones. And again, you no longer can hear the real world. It's replaced by the virtual world. And as you move your head around, we track the head's position and direction, and we can update again very fast, right? What your eyes see. Now, interestingly, our eyes can fuse motion only about 30 times a second or so, right? Which is why film works the way it works. But we can sense change in balance and movement of the head much faster. So that's why a virtual reality headset has to run at a much faster frame rate if you are not to feel nauseous or sick, right? And even with 120 hertz frame rate, it's generally not enough. I think we will see in a few years headset, at least double that frame rate, right? So one other thing to say about sensory hacking, right? So from the way that we define the metaverse, right, for our purposes, things like virtual reality or augmented reality are just ways to access this metaverse, to immerse yourself in this metaverse. So fundamentally, for me, I've come to this realization that VR, AR are simply subsumed by the metaverse, right? They're simply ways. And I believe that, a lot of the recent announcements from Microsoft and Facebook, et cetera, they point in this direction, right? Like you really need to think about the VR headset or the AR headset as just a means to access the metaverse. There's a more subtle form of immersion that is often overlooked, but is equally important, right? Which is this idea, and for probably the only people in the world who are aware of this immersion is game designers such as yourself, right? So there is obviously this idea of game mechanics, we know that the way that actuation and the core interaction loop works is when you actuate something in your virtual world, you want it to obviously follow your command, but not too literally, right? So if you move the mouse and the mouse goes exactly where you're trying to move, that's a very, it's a tight coupling, but it's not, it doesn't really have any game mechanics, right? But if the mouse actually had some physics to it, right? So if as you moved, it maybe overshot, came back, settled, right? That actually feels much more satisfying to us. I mean, that's why when on the, on the modern phones, when you scroll on a scroll, when you scroll a list, for example, and you reach the end of the list, you'll see a little bounce. Why is the bounce there? It doesn't serve any purpose other than to make that core interaction loop feel more satisfying. And that is basically what game mechanics is, right? And of course, there are games like Super Mario, even going further back to like Donkey Kong, that understood this concept. Even though they could not hack the senses as effectively, they could create very powerful immersion through using, really leveraging game mechanics. And it's definitely, as you design the metaverse, it's something that you should always keep in focus. Let's talk about this concept of navigation, which is a little bit more straightforward, but because we live in such a screen-bound world at this point, right? Like when we even talk about navigation, we talk about things like Google Maps or tapping on a game map to move to a certain part of the game world, right? We've got so used to navigation being this 2D map concept, right? But how do you navigate in the physical world? You just navigate by moving from here to there, all right? And so again, in our metaverse, you should be careful, right? As much as possible, try to create satisfying navigation paths. Immersive navigation should be a very satisfying activity in and of itself, right? um, yes, you can absolutely use maps, and you can use the idea of portals to jump around within large spaces. Nobody needs to spend 10 minutes going from one corner of your world to another. But while you are in the world, make sure that you think about that world as something that is meant to be navigable, right? And that navigation should feel immersive, should feel satisfying. And there's a similar idea also around interaction, right? Is again, because of this idea of screen based interaction, we've become so used to touching, tapping, pecking to do things in a digital interface. But in the metaverse, the idea is that it's very immersive. You are present. You're present in that metaverse. We want to try to create the illusion that you're not interacting with a digital representation, that you are in fact in that world. And if you go back, further in the history of industrial design, the way furniture is designed, the way that things like light switches, or the kettle is a great example, because when you look at a kettle, a tea kettle, right, the handle tells you how you're supposed to actuate, how you're supposed to interact with it. The steam that comes out of the spout tells you, is the kettle hot or not. You don't need a separate display. You don't need numbers and other things to tell you how to use this kettle, or what is its state. It's self-evident. The object itself is interactable, and by looking at the object, you can understand its state. And we've kind of forgotten this art in a way. We've gotten so used to putting labels and numbers and sliders and buttons, right? Like, there's an opportunity as you design for the metaverse to unlearn some of these things, go back to the simplicity of direct presence interaction. So with those sort of basic core ideas, let's put our definition back together, right? So the metaverse is a synchronous, shared, and persistent three-dimensional context where users, embodied as avatars, navigate immersively and interact through direct presence, right? So hopefully this definition now is more functional and makes a little bit more sense. Let's move to this idea of a metaverse design framework, right? So we want to, like, somebody tells you, like, hey, can you analyze Roblox and tell me how it actually works as a metaverse, right? I mean, where do you begin to unpack that question? Or let's say that you yourself, in your studio, want to design a metaverse. Where do you begin? How do you begin to even take that apart, right? And start thinking about the different aspects of the metaverse. So this design framework hopefully will help you both analyze existing frameworks systematically, but also approach the creative thinking around a new metaverse again in a very structured way. And the framework basically consists of three qualitative attributes and seven sort of quantitative dimensions, right? So let's run through them really quickly. One of the main attributes of a metaverse is what is its core mechanics, right? So is it a battle royale game, or is it social interaction? What is the core mechanics? What is the main sort of activity you are trying to achieve in this metaverse? The second is around value generation, right? So this is a little bit more subtle. Who is getting the benefit of being in this metaverse, and in what way? Perhaps how is it monetized? Or is it, is there an advertising purpose? Like, what is the value being generated and for whom in the metaverse, right? And then the last is around content strategy, right? Do you have a closed metaverse, as in, you control it and it's a proprietary sort of narrative, proprietary style, or is it more open-ended? In the way Roblox is it mostly user-generated content? Is it modding of existing worlds, which is something that, for example, Fortnite is starting to introduce? So the content strategy is pretty critical. It's the experience. Where are the experiences coming from? Who is creating them, right? And are the users allowed to participate in that process? And then if you look at it quantitatively, there are some key dimensions, and a lot of these we've covered. We've covered the idea of immersion. How immersive does it feel? And not all metaverses have to be immersive, by the way, right? So this is why this framework exists. You can decide how immersive or how synchronous your metaverse needs to be versus maybe it really needs to be persistent. If it really needs to be persistent, maybe you are storing the data structures of your metaverse on a blockchain, right? So, I mean, what is important for a particular metaverse very much depends on what is the purpose, right? How personalized is your metaverse? Does every character look different, or do you just get assigned some color and then that's the only level of personalization that exists? Twinning is this idea that for us, a duality is very, very critical, right? We are trying to bridge between the virtual and the physical. So for us, the extent of realism, both the physics, the visual fidelity, the photorealism, this is very important for us, because the promise we make to our customers is that the data that comes out of our metaverse is going to be interchangeable with what they have in the physical world, or what they would collect from sensors in the physical world. Scale is very important, right? How many people can be in your metaverse? One person, two people, five people, or 26 million people, as Fortnite had in its concert last year. And then interoperability, which is an idea we want to talk about a little bit more today, is really critical too, right? Are you able to take your avatar? Is the avatar, especially one that you've personalized, does it only work in Roblox? Or can you take that avatar to Fortnite, or from there into Meta's metaverse, right? What about the worlds you build? Are those worlds portable, right? Are the experiences portable? I mean, obviously, not all of this will be interoperable, but some aspects of this have to be interoperable in order for the metaverse to be a little bit more like the web, right? Where we are able to take certain things between websites. And this is just to, again, make this a little bit more concrete. I'll give you some very quick examples of applying this framework, right? So when we look at essentially, let's say Fortnite as a game, right? Its core mechanics is battle royale. The value generation comes from in-game purchases, and content strategy is obviously proprietary, right? Fortnite very much controls the style and the experiences that happen within Fortnite. Almost all game metaverses are highly immersive, very synchronous, because that's the only way you can play with others. Obviously Fortnite is a very scalable world, but then, things like twinning, this concept, as I was mentioning, of physical, digital, equivalence is not as important, or persistence is not particularly important in Fortnite, and so on. But in a different game or a different experience, they may be very important. Just as an example, Second Life is actually one of the original metaverses, right? And the core mechanics is really around social interaction. For us at Duality, the core mechanics is very much about running digital twin simulations, and the value our customers get. They're not engaging with Duality's metaverse to entertain themselves, right? The value for them comes from generating synthetic data or behaviors. And our content strategy is very asset centric, right? The focus is actually not on the experience, but having this sort of library of digital twins that are very accurate and match machines or environments in the real world. Awesome. So switching gears a little bit, I wanted to share a little bit the work we do at Duality and talk about some really concrete examples of what our metaverse is capable of. I want to start by saying that what we've built is not a game, right? And in the talk I gave last year, I sort of emphasized this idea of game engines as 3D operating systems. And in fact, I believe that game engines should probably rename themselves to be 3D operating systems, because I think calling them game engines is a bit of a disservice. So what we have done, with Falcon, which is our digital twin simulator or metaverse engine, right, is it runs on top of a game engine, in our case, Unreal. But what is loaded, the world, the environment, the machines, and even the initial state of that world is all loaded at runtime. And we're able to do this because we use a solid data model, in our case, universal scene description, to define all of this, right? And so those things get injected, if you will, we call it bar injection, into the application at runtime. And after that, the simulation can run either with human involvement, so human in the simulation loop, or without, right? And for us, it's all one and the same. And then finally, we provide a very flexible Python API that allows our customers then to integrate Falcon into their own workflows, right? So that's a very overall idea of the architecture. But here's an example of what we do, let's say, for a customer, right? So this was for a drone inspection customer that wanted to fly over infrastructure, in this case, energy infrastructure, right? Especially in sort of forested environments, and look for problems. It could be rotting in the poles, it could be chipped insulators, it could be vegetation that is encroaching on the utility corridor. And the drone is capturing this imagery, right? And then there's a machine learning model that tries to make sense of it. But that machine learning model can almost never have all the data it needs to find these things in the real world. So what we do is we build a digital twin of the world where the drone is going to operate. And then we make sure that it's able to produce all the images you see here come out of Falcon in real time, right? None of these are photographs. These are all images from the platform. And you can see on the right here that their machine learning model has been trained with this synthetic data. And in fact, in this case, a customer, it is a Fortune 100 company, took their drone, flew it back out in the physical world with that machine learning model that was trained with synthetic data, and showed that it actually could recognize the defects of interest purely by learning from synthetic data. So we've done this with numerous, with sidewalk robot companies, with self-driving truck companies. We have shown, again and again with our customers that learning either sensor data or machine learning models or behaviors in a accurate digital twin of the operating environment is as predictive as doing it in the physical world. But of course, you can do it much more quickly. That's why this customer saw a 10x improvement in learning in this way, and learning the synthetic data, or creating the synthetic learning data in this way. They had like a 10x improvement in cost and time compared to trying to do it in the physical world. Let me show you a quick demo of Falcon in action. So here you can see from USD, we are loading actually this particular scenario. And now we are, in this environment. This is not a game. This is an actual environment that exists sort of just north of Pittsburgh. It's called Laurel Highlands. It's based on real GIS data, right? And it's based on LiDAR scans of this area. But you can see that it is essentially very realistic. The way the drone is flying is completely driven by physics. If you look at the bottom left here, you can see the motors of the four propellers, right? And exactly what those motors are doing. And that's what's causing this drone to fly physically accurate way. You can see all the different sensor streams. I mean, this is why our customers, run Falcon, is because they're interested in that data that we get, not just from cameras, but from depth sensors, from lidars, from radars, right? This is another little example of something we are doing with one of the largest retailers in the world, where they are trying to build a self-checkout system. But again, they have thousands of products in their catalog. How do they build a vision system that can understand actually what is in your shopping basket, right? And so this is a little demo that shows how we can actually use physics to create these basket distributions at random, or product distributions in the basket at random. Literally, we can do millions of permutations, right? And not only do you get the sensor data, but you can also get the label data out of the system, right? You can get your which product is where, what is the depth of the different products in the basket. I mean, all of this labeling data typically has to be done by hand when you're working with field data. But in our case, we can generate that because we are working in a virtual world, so we can produce whatever data we want, and it's all ground truth data. That the label data is perfect match to what the sensor is seeing. And so just to sort of close out on this idea, right? So we are just at the beginning. They're just scratching the surface on what the metaverse is capable of. Again, thinking about the metaverse, I think it's actually helpful to think about the metaverse a little bit like a spatial internet, right? Because that's really what it is. We've taken, basically 3D spaces along with the assets and interactions that can take place within those 3D spaces, and we've virtualized it, right? And in that sense, I mean, there's this ability to create a massive, interconnected, parallel world to our physical world, but one that is capable of generating lots of data without friction, and changing aspects of how our physical world works so that you can solve certain problems. Again, this is being a technical crowd. I'll tell you, for me, the aha moment with the metaverse really came sort of based on one of my early insights from engineering, right? Is when I first learned about Fourier transforms, right? Fourier transforms are very interesting. You can take data that exists, let's say, in number space, and convert it to the frequency domain. So I don't know if most of you know, but like a lot of image processing works by actually moving the pixel data into the frequency domain and then doing operations there. You can operate in that frequency domain. You can run a low pass filter or a band pass filter and convert that back into the image space or the number space. But it's full, it's totally transformed. Now, trying to do those things in the number space is very hard or inefficient or not even possible. But when you convert it into the Fourier space, it becomes trivial. It becomes very easy to do. And for me, I think about the metaverse in that way, right? That you can basically transform certain problems into the metaverse, and then they become suddenly very solvable, especially data problems, right? Data at scale problems. And so I think that for me is really what excites me about the metaverse. Let's talk a little bit about the interoperability. So this I explained, and by the way, this looks very much like the core interaction loop we started with, and that's not by accident. That is exactly how we've designed Falcon to very much run as that core interaction loop. But let's look at another view on it, which is more of a cloud architecture view, right? And you can see that actually the sort of patterns we use to build our metaverse, to build Falcon, very much follow well-established web patterns, right? So we think about USD as that standard in the way that HTML is a standard. We think of our Python API very much like JavaScript, that way to actually bring execution and actions into the metaverse, but again, in a way that is very open and portable, right? Because Python, everybody supports Python. It runs everywhere, right? And similarly, we think of the application as more like a web browser, right? That's actually just where you happen to interact with the metaverse. And that could happen in the form of a proprietary headset like an Oculus or a Rift, or it could be on your phone, or it could be on a web browser. We don't care where that interaction happens, but that execution piece may be proprietary, but ultimately, because it's using open standards, that should allow a lot of portability between these different metaverse elements. And by the way, I mean, today we leverage the Unreal Engine, as I mentioned before. So, also in the early days of the web, like till standards really got crystallized, people would have, each web browser. I think some of the people who may have done web programming for a while may remember that each browser had a set of things it could do that other browsers could not. And so used to build websites that worked for a particular browser. But over time, of course, especially with HTML5 standard, that sort of fell away. And now all web browsers sort of follow a core standard. So I fully expect that the metaverse will not be fully open and interoperable from day one, but that is ultimately where we want to go. And that kind of sums it up. I do want to show you a quick demo of our metaverse before we wrap up. So I'm going to ask Rupesh if he can join me kind of in this demo. So I'm running this from a 4 or 5 year old MacBook Pro, and this is actually a proof of concept we've built for one of our customers who wants to basically show a wind farm. One of the things in the US, like when you want to build a wind farm somewhere for renewable energy, you have to get a buy-in from the community. But it's very hard often for people to understand what is the impact of this wind farm going to be on me, on my neighborhood, or my backyard. I don't care how it might look from some generic photograph. I want to know how it looks from my backyard. And so the idea here is to actually try to, again, through this immersiveness of the metaverse, help you understand the impact of a renewable energy project from your own backyard. Rupesh, will you join a walk around, and I can join as a friend if that's okay?
Just a moment.
Sure. And we're going to just continue. We have support for spatial audio as well in our metaverse. But I'm just going to. So there's Rupesh in our metaverse, so he can respond. Can you see me as well, jumping around, Rupesh? Yep. So this is not a game. So let me turn on, for example, this is the LiDAR point cloud. This whole environment was scanned. This environment, I think, is somewhere at the border of Oregon and Washington, right? This is several square kilometers area, and we have processes that will allow us to create these very realistic environments, but they're based on actual LiDAR scans and based on GIS data that we get. And here I can say, this is actually, we are actually in somebody's backyard, literally, right? And I may be the customer, and Rupesh may be the one who works for the utility company. But we can look at this infrastructure together. So when we say that virtualizing a 3D space, along with the assets and interactions, the assets here are these wind farms, obviously, and this actual neighborhood, the digital twin of this real neighborhood. And we've inserted these additional digital assets for the wind turbines. But then we are able to essentially look at it together, have a conversation. Imagine trying to have this conversation over the phone. You're like, hey, actually, if you move that wind turbine like 10 meters to the left, it's going to go behind my tree line and I don't care about it anymore, right? But how do you even begin to have that conversation right now without actually going to that person's house? And they may not want you to even do that. But in the metaverse, we can do that together. Right, so this is a very concrete, very grounded example that of the metaverse in action. Thank you so much, Rupesh, for joining me there. And I will stop sharing at this point. But we have a minute or two left. I'm also happy to stay over another 5 or 10 minutes if there are questions.
Yes. So there are 4 questions.
Sure.
I'll run you through one by one. So first question is, how is Metaverse different from MMOs like World of Warcraft or the Elder Scrolls Online? Some of the games do have immersive navigation, VR support, etc., which you already mentioned.
Oh, absolutely. So multiplayer games are the precursors of the metaverse. They're some of the earliest manifestations of the metaverse. I will say that in the way we think about the metaverse is more broadly than how you think about a multiplayer game, right? So one of the things about especially successful games is that the core interaction loop is very tight, but it's very driven by something you're trying to achieve for the game, which doesn't leave a lot of room for other types of interactions to happen, right? And so if you look at, for example, even Fortnite or Animal Crossing, right, the game mechanics may not be as tight or as focused, which actually allows for other interactions, social interactions especially, to take place. And I think fundamentally, so if you look at Falcon, right, I would never think of Falcon as a multiplayer game. It's not a multiplayer game. It is obviously something different, but I do think of Falcon as a metaverse, right, because I can do those kind of applications there. But you're absolutely right that multiplayer games are the precursor of the metaverse.
Okay, thanks for that. So the next question is metaverse, cryptos, NFTs. Do you think it's
Yeah.
the obvious combination going into the future?
It absolutely is, right? So so we say that, hey, the metaverse is going to be capable of all these different things. So then the obvious question is, what is the economy of the metaverse? Right now, if you look at the economy of both Fortnite and Roblox, the two largest metaverses that exist today, I mean, they're both closed economies and driven by in-app purchases, right? But of course, if you want something more open and interoperable, I mean, it's going to have to come from what is called now more broadly decentralized finance, right, or DeFi. So blockchain, crypto, NFTs, they all fall under this idea of decentralized finance, which is
True.
finance where there is no, or an economy where there is no central authority, right? But it's based on distributed trust. So yes, I believe 100% that the economy of the metaverse is going to be grounded in DeFi. Yeah.
Awesome. So the next question is there is real and valid fear of Facebook manipulating and taking over this space. Your thoughts?
I think that fear is reasonable. I have similar fears about every player in the metaverse ecosystem today, including Omniverse from Nvidia,
True.
Fortnite from Epic. Everybody wants right now. Everyone's trying to stake out their claim at this point, right? So the metaverse is a multi-trillion-dollar opportunity, right? And I truly believe this to be true. Uh, I think we are at a peak hype cycle right now. So obviously the hype can never live up to the reality. Building up the metaverse is going to take a lot longer. But of course, these technology companies are making they understand the size of the opportunity, and they're making significant investments in helping to bring the metaverse to life. And so it's understandable that they are trying to basically stake out their claims. But it's kind of interesting, right? Because the metaverse is only valuable when it is open, right? So if you go back to, do you know who funded the internet? It was not any company. It was actually DARPA. It was one of the government agency we are
Yep.
working with now, right? They are the ones who originally funded the internet for the US military to communicate, right? But then, because nobody owned it in a way, well, everybody owned it, right? And then it allowed this sort of flourishing of a much larger ecosystem. And I believe that that is not the case. Right now, a lot of the metaverse growth is pushed by commercialization. Um, and that is worrisome. I will say that is worrisome because you don't want things to get rigid or overly structured before some of these standards have a chance to actually gel. Fortunately, there are a lot of people who are working in this space, including us. Also our partners. Both Epic, AWS, Adobe, Autodesk. I mean, these partners are very interested in also seeing an open ecosystem. And so I think we just have to keep pushing for it, right? We just have to keep bringing up that conversation and keep pushing for it. But it's not a given. And we may take missteps. We may get, along the way, people may get locked into these closed metaverses for some time till we're able to break down those walls.
Awesome. So the next question is, people usually prefer or advise using GLTF as a 3D interchange format for web.
Mhm.
Any
Mhm.
reasons for not choosing that and going for USD over web?
Yeah, so I think GLTF is very compact. It's very efficient. And by the way, these standards are not totally resolved, right? So I will be the first to acknowledge that. What we believe is really powerful about USD is essentially it's a very flexible, very extensible model compared to GLTF, right? So in our case, for example, we don't just represent meshes or materials, but we also represent the physical characteristics of our machines within the same USD hierarchy, right? And that is very hard to do. There's no concept of that in GLTF, right? So the ability to think of it as like combining JSON with GLTF or something, right? Like we can extend the model in a very flexible way, which will be required again for a big open interchangeable metaverse. We're going to have to have a data schema or a data model that is a lot more flexible than just the ability to represent 3D meshes. There is another very powerful concept in USD, which is very important, is around this concept of compositing, right? So the idea that you may have an avatar that may be a base representation, but then you might be able to personalize that avatar through essentially an opinion on top of that base representation. And then furthermore, your avatar may have specific characteristics when you go into a particular metaverse, which can be done again as another layer, another opinion on top of those other two layers. This ability of layering and compositing data models or data properties, I think, is extremely important to both collaboration as well as the ability to create these kind of complex open systems. And again, that concept doesn't exist in almost any other data model that I can think of.
Thanks for that.
There are issues with USD. There are some issues with USD around speed, and we've addressed some of that in Falcon. We have gotten to a place where we don't have issues with that, because one of the things we allow in our USD hierarchies for Falcon is you can intermix USD assets and Unreal assets. And that goes a long way in removing some of the performance bottlenecks that you might have in a pure USD hierarchy. I talked about this at the last IGDC. If you're interested, you can go back and look at that talk.
Thanks. Next question is, apart from tech, what other concepts drive a successful metaverse? Economics, philosophy?
I think that design is very important. As I mentioned before, we have become so used to 2D or screen-based interactions that, and you start to see some of this in VR, but I think it hasn't been very systematic. I think VR tends to focus so much more on the immersion, not the interaction a little bit. But I think that with the metaverse, we kind of almost have to unlearn some of the habits, the UI habits, and the interaction habits that we have developed, over, like, especially building casual games or something like that, right? And I think really thinking about more innovative ways that are more satisfying. Like if you're immersed in the actual world, how do you interact in a way that perhaps is more, again, as I mentioned before, through direct presence? Or how do you navigate in a more immersive way, right? So those concepts, I think, we kind of almost have to unlearn some of what we've so systematically built up with 2D interfaces.
And there is a coming in
More
public
broadly, sorry. Maybe I'll answer the question more broadly, though. Maybe the person asking the question has a broader kind of idea in mind. So beyond the tech, and you could even argue that interaction is a part of, let's say, the tech stack. I really think that with the metaverse, again, we have an opportunity to build something that is truly inclusive and allows for better communication, more sort of satisfying kind of interactions. Or we can have the negative. We've seen that even though some of the technology that has come before, such as social networks, right, while they had the promise of being very positive, they also have very negative second, third order effects on society. And so I think it's important for anyone building metaverse experiences, designing metaverse experiences, to really think about what some of the second or third order effects might be, and really if you want a better world for all of us to live in, I think it's important to think about those things.
So one final question. What are the career opportunities specifically in Metaverse?
Awesome. Yes, I think it's just getting started. It's going to blow up. So if you have 3D chops, if you are able to model, or a technical artist who's able to do um, programming in the 3D operating system, aka game engines, um, there is an infinite opportunity right now. I'm telling you that there is so much need for talent that it's not even funny, right? Um, I want to make a plug for us, for Duality as well, while I have your attention. So we do have, as I said, a small team in Mumbai, which is growing. So if you are interested in helping to build a metaverse, either creatively or technically, uh, or in any other way, right? Uh, Please do reach out, right? And you can go to our website, duality.ai, and in Teams, maybe there's a position there that is open that interests you, or if there isn't even a position, go ahead and just, there's, I think, a button below that says, just, you're interested in this space. We want to hear from you. Absolutely, we want to hear from you. And
Yes.
again, I think it's just getting started. I think the demand for talent is going to far outstrip the supply for many, many years.
Right. All right. So I would like to thank Apurva for a very insightful session. The drone demo you showed where Pittsburgh was recreated looked really fabulous. Not to forget your backend platform, Falcon, doing all the magic. We highly appreciate your time and being with us, helping our Indian gaming fraternity with your guidance and advice. I would like to thank the audiences for being patient and staying up late for this talk. We would like to take a moment and thank all the sponsors, presenting sponsors Unreal Engine, gold sponsors MPL, AWS Glance and Jungle Games, Legacy Silver sponsors Game Mission, Laksha and Yes Genome, bronze sponsors Quali and Gameon, Hyper Casual Track sponsors Sunday, IP Connect sponsors Succeed Innovation Fund. Thank you all once again and good night. Apurva, I'll see you in.
Bye bye. Bye bye.